Now in this activity, we'll be studying about the products created during a combustion of a fuel, right? Especially here we are discussing about during a combustion of a candle like this. Okay, what are the products which are getting created? So I have prepared a certain apparatus here with several materials. So one by one I'll let you know what are these things. So here first of all we'll be needing a stand. So this stand is being used to fix all the other materials firmly, like in this setup. Okay, so then we'll be needing a funnel, right? That funnel is being used to direct the smoke which is getting emitted from the candle towards the system which is in here. Okay, so the delivery tube which allows to flow gas or the product which is coming from the candle. Then here you can observe a U-shaped tube. This is a U-shaped tube. It's been like drawn into a shape of a U, right? And the smoke which is coming from the delivery tube going through this arm of the U tube and traveling to the other arm as per to the apparatus. Then at the two ends I have stopper it, right? I have applied several stoppers at the two ends so that the gas which is coming from here is going through there to the next arm, and it is getting exit from the nozzle in here towards the other vessel which is on here. Okay, so inside the U tube here you can observe there is certain chemical. In here there is one certain chemical, right? This chemical is copper sulfate. This chemical is copper sulfate. Especially this copper sulfate, this type of copper sulfate is called as anhydrous copper sulfate. Anhydrous copper sulfate. Usually if you take copper sulfate, it will be like this. Copper sulfate, usually it will be like this. See, this is usual copper sulfate. It's in blue color. See, it's in blue color, right? Usual copper sulfate. This is hydrous. Hydrous means it contains or it absorbs water. So this is hydrous copper sulfate. So anhydrous copper sulfate means after heating these copper sulfate, you can take some amount of blue color copper sulfate and you can heat it. So when you heat copper sulfate, the water vapor which is absorbed to the copper sulfate crystals will get evaporated, and the copper sulfate crystals will turn into a white color like this, which is in the U tube. Okay, so this is anhydrous copper sulfate, okay, which I have prepared by heating up hydrous copper sulfate. Okay, so when there is water vapor, when water vapor is getting absorbed with copper sulfate, the color of this copper sulfate is getting into once again blue color, the original color of copper sulfate. Okay, but in order to do that, it should be come in contact with water vapor, and those water vapor should absorb into the copper sulfate crystals. Right then, so then finally the smoke coming from the candle goes through this delivery tube to the DU tube. Then after that, from the second delivery tube towards this vessel. So this vessel contains lime water solution. You can observe it is colorless, right? The lime water solution, it is colorless, do not contain any kind of a color, right? So it's a colorless lime water solution. So the smoke which is coming out from the candle passes through the candle towards the delivery tube, towards the U tube, goes through the copper sulfate crystals, anhydrous copper sulfate crystals, comes with the other arm and goes through the delivery tube here and comes down and travel through, or it's getting bubbled through the lime water solution, right? That's how these apparatus work. But there is a certain thing, we have to connect this thing to an aspirator like this. So I have to, like, you know, we have to suck the air particles out of this system so that the smoke will come directly towards this delivery tube, towards the U tube. Otherwise, if the flame of the candle is going here and there, we can't get a direct observation clearly. So therefore, I have connected this system to an aspirator, right? So when the aspirator is working, the gas inside this system is getting sucked out from the system. So therefore, the flame or the products created in the candle is going to emit only towards the U tube and the other system. So it's important to connect this aspirator, otherwise the flame will go here and there and the products which are getting created will not flow towards these materials. So getting observation would be quite difficult. So therefore, aspirator is providing a time, like enough time to get a good observation from the system or from the experiment. So we'll conduct the experiment and we'll see what are our observations within this setup. Right. So I'll ignite the candle first. Then we'll see what's going to happen. So first of all, I'll use the candle and fix it to the wall like this. Right then, so I have prepared the system right now. So we'll operate the aspirator and keep the candle flame somewhat steadily so that the smoke is coming out from here. So that the smoke which is coming out from the candle is going towards the system to my right hand side. Okay. Right, so we'll operate the aspirator then. Right, so here you can see that the aspirator is working now. So the candle flame or the product which is getting created is coming towards the anhydrous copper sulfate crystals. You can see it. So we have to give it somewhat time, right? So that the products which are getting created during the combustion of candle to come in contact with the chemicals. So here you can observe now gradually the color of lime water solution is getting converted into a milky white color. Can you see? Now when I was conducting the experiment, so when initially this chemical was in the system, the color was like the color of water. Now it's been turned into a milky white color. Here you can observe it. See? And here also we can see that gradually the copper sulfate crystals are also getting converted into light blue color. See? Gradually it's getting converted into light blue color. So we'll give out somewhat time and let's observe. Right, my dear children. Now here you can observe our observations very clearly now. So I have let it for some time and now we can observe pretty much good or pretty much clearer observations. So here you can see copper sulfate solution. So I'll stop this aspirator, right? So I'll stop it now. Okay. So now let's see. First of all, I'll put off the flame in the candle, right? So now gently I am going to remove this setup to show the color of copper sulfate. Right. Okay then. So here you can observe the color of copper sulfate in here right now. See, the color of copper sulfate solution, it has converted into a blue color, right? We can observe it. It has converted into a blue color. You can see it very clearly. It's been converted into blue color. Means like this copper sulfate, I'll take the actual copper sulfate. So like this, it's been converted into blue color. So original color of the copper sulfate was white color. So when white color copper sulfate, white color copper sulfate means anhydrous copper sulfate. White color means anhydrous. There is no water. So when white color anhydrous copper sulfate come in contact with water vapor or water, it's getting converted into blue color like this. So this is called as hydrous copper sulfate. So due to that gas which is coming out from the candle containing water vapor, this copper sulfate has got changed into blue color once again, right? So we can conclude from this experiment, from this observation, we can conclude that during the burning of candle wax, water vapor is getting emitted. That's why the anhydrous copper sulfate has got into a different color which is the blue color. Now I'm going to keep it. So I'm going to ask you a simple question. Why do we need to keep a water trough like this? So you saw that I kept the water trough like this and dipped it inside the water trough, and I have fixed it to the two delivery tubes by keeping copper sulfate within the water like this. So what's the reason of dipping this U-tube inside the water trough? It's because the vapor which is coming out from the system is getting cooled down due to the water which is contained in the trough, right? It's getting condensed. Water vapor which is coming out from the delivery tube is getting condensed due to less amount of temperature within the water trough. So to cool the vapor or to cool the products which are coming out from the candle, we can use this water trough, right? Okay. So now let's come on to the other vessel where we use the colorless lime water, right? So here you can observe that the colorless lime water has got also a milky color, a milky white color. This is because of carbon dioxide. From grade 6 onwards, you are going to study that. You are being studied from grade 6 onwards. The lime water, colorless lime water, can turn into milky white solution like this with the presence of carbon dioxide gas. So here also you can observe the colorless lime water has got changed into milky white color. That's because of having carbon dioxide. That's because of having carbon dioxide gas. So where did we receive carbon dioxide to the system? We received carbon dioxide to the system by the burning of candle wax. So here, by using this observation where the color of lime water change, so here this observation can be used to identify the presence of carbon dioxide gas during the burning of candle wax. So this activity finally concludes. During the burning of fuel, or else during the burning of candle wax, the main products which are getting created are number 1, water vapor, and number 2, carbon dioxide gas. So let's head on to the classroom and we'll write down our observations and conclusions from the activity. Right, my